Ladies and gentlemen, so this is where we stopped last week. This one, right? It's a demonstration of the construction of the confidence interval for population proportion. Hey, in statistics, always keep in mind that proportion and the idea of a proportion and probability are often, you can say always, interchangeable. They are equivalent. They have an equivalent meaning, all right? Equivalent spirit. Understand? They are, I sometimes I use them interchangeably. Sometimes I say, oh, P is the proportion, and sometimes I might say P is the probability because they are, the two terms are interchangeably used. Okay? What happened? Right? Okay. Now, margin of error. Margin of error. Okay. Using the example of the proportion of nearsighted students. Okay, the proportion is 58, 0.58, or you can say 58% of the students are nearsighted. All right, this is the fake proportion. Okay, or estimated, not the true value. Not the true value. Okay? However, the true value, true proportion, has 90% probability that to lie within the neighborhood of p hat of size. Of size z 0.1 divided by 2, okay, the square root of n, and p hat, q hat, q, where q hat is 1 minus p hat, okay? and we call the size of the neighborhood the margin of error. Margin of error. Okay, keep that in your notebook. All right. Okay. So denote E equal Z sub alpha over 2 square root of n. All right. P hat one minus P hat. Okay. Margin of error. The size of the neighborhood or the size of the neighborhood of P hat. Okay. So this is P hat. All right. This is its neighborhood. The neighborhood is called the margin of error. All right. Where is the margin of error? So where is the end point on the right? It is P plus E, P plus D sub alpha over 2, square root of n, square root of P, 1 minus P. Okay? And this is P hat minus E, okay, which is minus Z alpha divided by 2. Square root of n, square root of P hat, 1 minus P hat. All right? And this is called neighborhood. The size of the neighborhood, this is the neighborhood. This is also the neighborhood. Neighborhood on the right and the neighborhood on the left. Okay? So this is the margin of error. Okay? So it is very likely that because the probability is 90%. So it is very likely that true value, hey, true P lies in a neighborhood of the fake P. Okay? So that is, suppose that. Now suppose that here. And suppose here is the true P value, true P. Then P minus P hat, the distance is smaller than E. Okay? So the arrow, this is the arrow. So we can say the arrow has a 90% probability to be smaller than E, because this is the distance. This is P hat, minus p. Okay, the distance. Or you can say the arrow, the distance between the fake one and the true one. Okay, this is the distance between the fake one and the true one, or the true one and the fake one. Okay, so we can say that the arrow has 90% probability to be smaller than the margin of error. Okay, I'm a little dizzy because I'm having a cold. Okay. Here. So now look at the function. Let's focus on the function. P1 minus P. Okay. Hey, you see this? This is the function. And it is 1 over 4. Okay. And this is P1 minus P. Okay. This is G of P. And this is G of P. G has maximum, global maximum. At 1 over 2. Because GP, which is equal to minus P squared plus P. Okay? And it is equal to P minus 1 over 2 squared plus 1 over 4. So it is smaller than 1 over 4. Okay? So this is the maximum value. One over 4 when P is 1 over 2. All right. So E equal to Z sub alpha square root of n P hat 1 minus P hat. If you want them to be should be smaller than Z alpha divided by 2 square root of n, and this is 1 over 2, 1 minus 1 over 2. All right. The upper bound upper bound of arrow. The upper bound of the arrow. Which is equal to Z alpha square root of n 1 over 2. So we take the maximum value. So taking the maximum value of E as E equal Z alpha 1/2. If you want them to be smaller than sorry. Sorry. This is not E, sorry. Not yet. So taking the maximum value of Z sub alpha and P 1 minus P hat to be this one, the maximum. And it's smaller than E. Then should be the minimal minimum sample size, which ensure that the arrow is smaller than E. Okay. The arrow is smaller than E. Okay. So what about, hey, sometimes we let's consider, for example, E equal 0.03, for example, and alpha equal 0.05, for example, then in this case, and should be bigger than, or should be at least 1.96, 4 times 0.03 and square, which is 1067 point something over 1.68. All right. Then this implies that when n is at least okay 1068, and then p hat, p minus p hat, which is the arrow, has 95% probability to be smaller than 3%. Okay. This is what we often this is what we often hear that in news media, in election, during election, during election. During election. You see that? Okay. Now it is empty. I will fill it. Okay. This is what we so let's Google. Let's Google. Election. Let's Google it. Okay. Election. 3%. Error. 3% of error. Sampling. Supporting rate. Supporting rate and presidential election supporting rate, sample size. Okay, sample size. Understanding the margin of error in election polls. Okay, that's what that's what we have been told during election, and that is also what we will be told in future election, because the theory always hold before and after the election. It always hold at all times. because it is a statistical theory. It is always true. Okay? From now or before now. Okay? It is always true. Understanding the margin of error in election polls. What is what they open? 3%. Fine. Hey, the notion that a typical margin of error is plus or minus 3 percentage point leads to people to think the polls are 3%. That's Google. Yeah, here. 3% here. 3% sample size. What is that? The margin of error. Oh, when you hear the margin of error is plus or minus 3%. Copy and paste. Let me rewrite this. Wait. And wipe off this. Yep, here. This one. Hey, okay, look at this. Bigger. Yeah. As anyone who follows the election polling can tell you, when you survey 1,000 people, hey, to be more precise, it should be 1,067 or 1,068. Okay. So they are they clip to the to 1,000. Okay, they clip the number into 1,000 because 1,000 is more simple, easier to remember. Okay, to memorize. Okay, and it is and 1,000 is very close to 1,067 or 68. Okay, the margin of error is plus or minus 3 percentage points. This roughly means that 90% of the time, the survey estimate, hey, p hat, this is p hat, okay, should be within 3 percentage points of the true answer. Hey, this is the p, the true value of p, and this is p hat. This is p of true answer. This is p, and this is p hat. E.g. means, for example, the support rate of Donald Trump. Okay, the true support rate when you survey 1,000 citizens, voters. Okay, for example, 40 4 9 495 of them support .495 of them report their support for Trump. Then the support estimate, support rate estimate equal T hat equal 49.5%. Okay, and you don't worry, the fake value. Don't worry. While T hat equal 49.5% is the fake value, not the true one. Okay, the support where P is the support rate for Donald Trump. But don't worry, the distance, the error, P hat minus P. has 95% probability to be smaller than 3%. Okay, that's how we should interpret the polling results. Okay, and it's going to appear in your midterm exam. All right, it's going to appear in your midterm exam. Okay. So that's the end of the end of chapter 7. The end of chapter 7. All right. That's the end of chapter 7. And I'm not going, but so we now finish. We now finish chapter 7, but I'm not going to proceed. We are not going to proceed to chapter 8 directly. I'm doing something else. I'm doing something else. And before I do the something else. Okay. I must tell you the reason why. Note that. Note that in statistics, there are two main tests. Okay. Estimation and hypothesis testing. Hypothesis testing. Okay. So this is the estimation. And this is the hypothesis testing. Okay. One population and two populations. Okay, one population and two population. Okay. Okay. So it's 1, 2, 3, 4. Okay. And regular. Um, order is 1, 2, 3, 4 in most textbook. But in your textbook, the Blumen, the order is 1, 3, 2, 4, which is weird. So I will go by the order. I will go by the order. 1, 2, 3, 4. Okay. So let's go to chapter 9. Is it chapter 9? Yeah, chapter 9. And jump to okay. We will be back to chapter 8 later. We will be back to chapter 8 in later weeks. Okay. So roll call. I forgot. I forgot to make a roll call. Hey, here. Roll call. Get ready. Here. Get ready. Hey, the lower one. 1 minute, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Okay, that's it. That's it. Not anymore. 10 minutes break. How many break? Hey, um, oh, I need hot water. Okay. Wait a minute. Your turn. Here, in your turn. And so that is why we will move to chapter 9 here. And I wanted to finish estimation, all the estimation part, and then proceed to hypothesis testing part. Understand? And here, this is chapter 8. And this is also chapter 9. Right? Chapter 7. Right. Anyway, my order is 1, 2, 3, 4. Now it is in your chapter 7, chapter 9, chapter 8, chapter 9. So what I'm going to do is now we finished chapter 7, and now we will move to chapter 8. And then chapter 9, sorry. And then I will go to chapter 8 and then chapter 9. Okay. Chapter 7, chapter 9, chapter 8, and chapter 9. Okay? That's our order. Here. Chapter 7, chapter 9, chapter 8, and chapter 9. All right? So that is why I don't recommend this textbook. Unfortunately, this one is not my it is not my decision to make. I cannot decide the choice of textbook. If I were the one in charge of choosing the textbook, I will not choose this one. Okay. So let's go to chapter 9. So two population. Estimation involving two population. Two populations. Okay. And suppose that x1, x2, x3, all the way to xn1 are IID independently and identically distributed normal random variable. Mean is mu1 and the variance is sigma 1 squared. Okay, and we have y1, y2, y3, all the way to yn2. They are also IID normal random variable. Okay. Mu2, sigma 2 square, understand? And the two sample are independent. Okay? You see that? Okay. And now it can be shown that x bar minus y bar, okay, are distributed as the normal random variable mu1 minus mu2 and 1 sigma 1 squared plus n2 sigma 2 squared. You might ask a question. Are you sure, Professor? Is this plus or minus? Observe that. Observe that this is plus sign. Not minus. Okay? All right? Hey, look at this. Let me copy from this page to help you recall. To help you. Okay? Yeah, here. Copy from the previous slide. Okay. Where X bar is the average of X. Y bar is the average of Y. Okay, if you calculate their average and denote the average by X bar and Y bar respectively, right, this is a random variable. And so is this. Random variable minus a random variable is also a random variable. The new random variable must have a new distribution. Understand? So what is the distribution? Because they are all from the normal distribution. So the new random variable is still normal. Okay? And there are two parameters in a normal distribution. First is the mean, and the second is the variance. So this is the mean value. This is the mean value of the new random variable, and this is the variance of the new random variable. It can be shown that. And it can be also shown that the expectation of x bar minus y bar is mu1 minus mu2. The mean of the new random variable x bar minus y bar, and the variance of x bar minus y bar is n1 square sigma 1 square plus n2 square and n2 sigma 2 square. And note that this sign is plus, not minus. The variance, which is the variance of the new random variable x bar minus y bar. Okay? Right? Any question? Okay. So that's why. So x bar minus y bar this is why x bar minus y bar has the normal distribution with mu1, the first parameter mu1 minus mu2. Okay? And n1 sigma 1 square plus n2 sigma 2 square. With this, we can derive the confidence interval for mu1 minus mu2. Hey, there are two populations. Now we have two populations. Hey, here are two populations. So here are two populations. Here are two populations, okay? So we have two populations here. So let us take a look at an example. And this example has no number. Hey, when you see there is no number for an example, it means that this example is mine, not from your textbook. Okay? And now, suppose that Hong Kong University and AU University student, boy student height. Are both normally distributed. Where are the other students? Why so many absent students? What happened to them? Huh? What happened? Are both normally distributed, okay, with standard deviation. Um, 4 and 3.5 respectively. And then when you see this, you should know that this is a sigma 1 and this is a sigma 2. All right. Okay. Then um 0.95 equal to probability x bar minus y bar minus mu1 minus mu2. Oh, sorry. Okay. Probability of the normal distribution smaller than 1.96. Understand? Note that x bar minus y bar has the normal distribution mu1 minus mu2. Sigma 1 square, sigma 2 square. Okay, then x bar minus y bar. This is not available in your textbook because your textbook never derived the formula. I do. Is distributed as the standard normal. When we have standard normal distribution, then we can do something. Okay, this is what we need. Hey, this is going to appear in your final exam. I will give you this expression and ask you what is the distribution of this random variable? What is the distribution of this standardized random variable? You should say, oh, this is the standard normal distribution. All right. So now this is the standard normal distribution. Hey, now we have a new random variable. Hey, don't look at this. Don't take this as two random variable. It is now one random variable. This is one. You can define it as z. Okay, a new one. Hey, you look at this and think of it, and think about this is one random variable, not two. Okay, and a normal random variable can be standardized minus mu divided by the standard deviation of this random variable. Understand? Now, this is normal, and so is this. This is the standard normal, and so is this. This is also standard normal. Now I'm replacing this. I'm replacing this with this. Okay? Understand? It is not available in your testable. Not available in your testable because your testable never derived. Right? Okay, this is equal to probability x bar minus y bar minus mu1 minus mu2 divided by the square root of n1 sigma 1 square plus n2 sigma 2 square. Okay, smaller than 1.96. All right, and this is equal to probability I changed the order because it is in the absolute sign, so the order does not matter. All right. Right? Sorry. Okay. And now I look at this. So okay, and this is equal to this is very similar to the one population scenario. Okay, so the 95% confidence interval for mu1 minus mu2 is x bar minus y bar minus 1.96 x bar minus y bar plus 1.96, the margin of error. Okay? To generalize. The this is the way we generalize in the one population situation. All right? This is this is our conclusion. Hey, the formula is very similar to the one population situation. Okay? Mu1 minus mu2 is the confidence interval for mu1 minus mu2 is a neighborhood of x bar minus y bar. X bar minus y bar minus something and then plus something. Minus margin of error and plus the margin of error. Hey, it is going to appear in your in your midterm exam. Okay. So the confidence interval for the difference in the mean height of PKU and AU boy student height is 95%. And one sigma sigma one is 4 square plus n2 3.5 square and x bar minus y bar plus 1.96 and 4 square plus n2 square 3.5 square. Okay. Okay. So what time is it? Oh, we still have time. Now suppose that two samples are drawn from the two schools. And two samples of size 150 and 100. We still have time. And denote them by x1, x2, all the way to x150. y1, y1, sorry, y1, y2, all the way to y100. The sample means are respectively 176 and 174.5. Then we have the numerical valued confidence interval for mu1 minus mu2. Okay, so the confidence interval, 95% confidence interval for mu1 minus mu2. The difference in two schools. Mean height of boy student. Okay, is given by 176 minus 174.5 minus 1.96, 150. 150 4 square, 100 3.5 square. Okay, and 176 minus 174.5 plus 1.96. Likewise, okay, and let us finish it. Let us finish it. Okay. And this is 0.4787. Okay? 4787. Okay? So this is so it is 1.5, sorry. 1.5 plus minus, sorry, minus and 1.5 plus, okay? And this is going to appear in your midterm exam. Let us make a comparison. This comparison will help you to understand the formula. You don't memorize. The formula, the number of formula you need to memorize is only one, not two. We now have two formula, right? This is the second formula for confidence interval for in the case of two population. But this formula is very close to that in the one population situation. And now I'm going to make a comparison. And this comparison will help you to understand. Okay? But our time are quite limited. It is almost 12 o'clock, and I have a meeting to attend. So with that, let us just stop here. And the comparison will be made next week. Okay? The comparison next week will help you to understand the formulas. And you will find that the number of formula you need to memorize is only one, not two, not three, not four, not five, because later we will have many, how many? Later we will have about 9 similar formulas, 9 similar formulas. But you will see the pattern, okay, the principle of the formulas, 9 formulas can be condensed into one. It is only one formula you need to memorize, not 9, okay? So let's make the comparison next week and see you next week. Okay, I'm so busy, I cannot keep talking, okay? And I have a meeting to attend, so we stop earlier. See you next week. Oh yeah, roll call. Roll call. I need to make a roll call. Hey. I need to make a roll call.